All right, so I just want to go through a quick example of graphing the inverse of this graph. So I didn't give the equation or anything, I'm just giving you the graph of f of x. So we talked a lot about the inverse graph is reflected across the line y equals x, which is this diagonal line that has a slope of 1. So it goes up 1 over 1 in both directions, and your inverse should be a reflection of the original over that line. Okay, so I'm just going to use that as a frame of reference for when I have my inverse graph. I want to make sure that it appears that it's a reflection across that line. So we talked about getting a couple points and then flipping the x and y, because we learned that when you get the inverse, all of the x's and y's properties are just reversed. So what I'm going to do is I'm just going to write down a few of these points. So -2, +2. This is 0, 0. 2, -2, and let's do a couple more here. So 1, 2, 3, 4, so 4, 0, and then finally 1, 2, 3, 4, let's do 5, 1. Okay, so I did that middle point. This is important to do, and then just a couple on either side of that. And then what I'm going to do is for the inverse, my x's and y's are just going to flip. So this would become 1, 5, this would be 0, 4, this would be 2, -2, 0, 0. When you flip that, it just remains the same. And then this would become -2, +2. Okay, so I'm actually going to start with that vertex point just so that I can figure out where that's going to be located on my inverse graph. So that was 2, -2. So that's here. So this is the first one that I'm going to graph for the inverse graph, which is -2, +2. So that's this point right here. Let me grab a different color. All right, -2, +2, and then I'm going to graph the other ones. So 0, 0 is going to stay at 0, 0. 2, -2, so 2, -2. 0, 4, 1, 2, 3, 4, and 1, 5. So over 1, up 5. So knowing that this is the vertex point, I know that my function is going to start there and then stem out in those two directions. So it's going to start here and branch off. And then it's hard to tell because these points are exactly on that line of the original one, but we can draw it in anyways, like this. So although this looks kind of crazy, what we have is this original V reflected, and now it is a sideways V, okay? And if you look at the line y equals x, you can see that this reflected here, and then we can also see that this reflected across here. So again, that's why it's hard to tell because it's right on that line. I can highlight this a little bit better, the inverse, so that you can see it. So that would be the inverse graph. Okay, and again, the main thing, you can graph anything as long as you can get points from the original and you can reflect them. You can graph the inverse of any function that's given to you on paper.